In the first part of the video, we were left with all the work on the crankcase. So we had completely opened the hole for the reed valve. We had resin coated it in all its parts. We put the screws and we had to bring it into rectification. It was picked up from rectification and this plane has been made, as you see, both here and on this other side. So what should we do now? First, we'll have to remove the excess resin that is inside the reed valve holder, so this here. Smooth it out, smooth the tip of the self-drilling screws, and then fix a little bit here. Make the surface more even. And then once the crankcase is coupled, I'll show you. Here it is. We will have to go to work in this area here, because this area we'll have to make a slide that can direct the incoming flow as much as possible towards the center of the tree. Then we'll try the tree and see how we can do it best. Then today we'll also see this. We already seen this. We'll close all the holes with the resin and we prepare it to then do the processing to make it work with a 40 carburetor. Let's move on. We have for material Krimac clutch with synthesized discs. With all its parts. On these powerful engines, it's always good to use clutches of this type, which are very light but also very performing, in the sense that they withstand considerable stresses. We also use them in acceleration races. This clutch has a flaw. It's not really a flaw, it's just like that. It detaches with very little lever stroke, and when it attacks it does so very strongly because it has aluminum on discs that create more friction than the others. So it's necessary to employ this kit sold by Krimac so that the lever becomes softer and the stroke becomes longer, so that you can do better, so that you can better dose the clutch attack. However, for street engines, in the end, even its original slowdown is fine, but this makes the clutch work really better, so I recommend it. The clutch and its push rod, even if it costs a little. So we have the clutch, and then we have the Parmakit ignition machined from solid. We will then evaluate whether to leave this fan or replace it with a more effective one, because as we showed you in this video dedicated to cooling, this specific shape with many small fins doesn't cool well at high speeds. Of course, this engine will not run a lot, however it would be better if it had an efficient cooling, also by virtue of the power produced, which should be quite a lot. This is 2.5 kilograms, and I always recommend flywheels of this weight if we talk about ignitions of this type. Therefore, the IDM stator, because they allow both to make the clutch work well and to make your own engine work well. So always use flywheels a bit heavier, even on racing engines. Above all because the diameter compared to a Piaggio flywheel, even if it weighs 2.4 kilograms, is much less. So the inertia generated by this flywheel at the same weight with the Piaggio one will be significantly lower. Let's move on. And one thing I forgot to tell you before. Do you remember here there was a weld overlay because the thread had been damaged with the cutting of the cusp? The thread has been redone and the top has been redone, so now everything is in place and it's ready. Then, with the help of an indelible marker, we go to mark the part to be removed on the flywheel side. So we mark. Then we could do further checks, but it's just a reference. This way we should have been able to replicate the shape of the opening, the shape of the opening on this side as well. Now, with the usual electric tool, we are going to file this part to smooth at least 1.5 centimeters on this band. We have roughed the crankcase with the big cutter. In the meantime, I mounted the 4 locking studs on the other half crankcase. So now the finishing of the surface and of the inner surface of the pack holder, we'll do it with the Dremel. And then we'll do it with the rolls in order to give the surface a smooth finish already, as it should be. Already after the first roughing on the flywheel housing, it's possible to see how the flow is already better oriented in the center of the crank chamber. We already oriented more or less the center of the shoulders. Let's go to the finishing. As I had anticipated, today we'll also work on the reed valve. We'll fix it. We will not complete the operation because I'm still building, and we'll see it in the next video, the steel plate on which to then put the manifold, which will be obtained from an original muffler for PX 125-150, therefore which has the suitable internal diameter. It's 40. So I put this off right here so you can see how it's done. It is from an old TM go-kart. It's made of plastic, but we have to plug these holes because otherwise the gasket, the outer edge of the gasket will end up outside the solid part of the flow guide. So here we will fill everything with the resin and then we'll enlarge it to the extent that concerns us. Here the resin has been applied. We have put in more than necessary. Clearly then, once it has dried, we'll remove the excess before working it. A bit of it is left over, so I think I'll attach it here, where the famous hole is, to be sure not to break through. The resin has hardened and we're going to use this tool, which is a handheld rotary sander, to smooth it out. We'll rest it here and work on the surface. The plugged and sanded flow guide looks like this. We put it inside the reed valve pack and then we put it outside, and we'll go on to continue processing it when we also have the flange. Let's see what happens on the intake when the piston goes up and down. We are now in this position near the bottom dead center. As you can see, the passage is small, but here it is, it's here on this side. This is why doing the slide on the flywheel side was a wise thing from a fluid dynamics point of view. It's clear that here we could benefit from an additional passage section by making a slight chamfer on the crankshaft. Then, when the piston goes up, here it is, there is a classic valve opening, because the shaft derives from that. There you have it, the tree has been worked. As I had anticipated, I limited myself to smoothing the band, this part here that is empty, to smooth it a little towards the center in order to remove as little weight as possible. I could have cut it directly and had maximum passage, but then I would have lightened the tree too much. I also removed the tooth of the band that closes the original valve because the resin on the clutch side protrudes slightly on the seat. Since I do not want to remove the resin, I remove the tooth because the part of the resin that is anchored on the seat of the tooth guarantees me the seal of the resin itself. I will not rebalance the crankshaft, so to speak, because it only falls back slightly, and from experience, having tried it, I can tell you that small imbalances in general don't do much from a vibration point of view. But especially if the shaft falls back, even so, for example, it will not vibrate. This is proven on these large frame engines. Let's conclude the fluid dynamics speech as regards the pump casing by looking first one casing at a time, and then both casings close together, doing the same test we did before to see how much the change is now. We put the insert. I'll try to make you see better. At bottom dead center. Now this is the situation. See? Quite another thing compared to before. This way, the reed valve can pick up the signal from the muffler quite well. Why is it important to have passage, or at least enough free space with the piston at bottom dead center? Because it's the moment in which we transfer and the transfer and the exhaust are both open to the maximum of their section. So what happens? If the muffler is effective, it can give a signal to the reed valve, and that is the only reason why we look at this thing. On the other hand, on flywheel side, the situation is better, because the BGM tree originally has this cut to balance it. Therefore, by moving the crankshaft near the lower dead center, we will still have a well open part. However, this chamfer we have made is necessary, because otherwise the transit is very poor. Now let's close the casing and see what happens. Before closing the casing, I'll show you how the situation is from the inside. So gases can do this. Here, compared to what was the initial situation, we have improved a lot, because now with the piston at bottom dead center, we have the right passage adequate in order to take advantage of the signal.
If you like this video, leave a thumbs up and share it with your friends. Remember, White One Racing is not a workshop, but an amateur sport association that works on engines only for sport purposes and only for its associates.